Hello, everybody. We are on day 6 of our 2.5 solving section, solving quadratics. And the focus of today really is working in the real world. So this will be hint notes for each question if you were not sure how to start. So I will help you start, and then if you've done it, then you can check that you started the same way. We'll all be checking for answers. We'll check for accuracy tomorrow, but this is strictly to help you get started if you weren't sure how to approach a certain question. You do not have to watch the whole video. If you, for example, you're all set for 1, 2, and 3, and you didn't know how to start 4, go jump to number 4 in this video. Starting with number 1, if an object on Mars was dropped from a height of 237 feet, how long would it take to travel half the distance to the ground, round to 2 decimal places? Well, the key here is that I see this word dropped. So as soon as I see the word dropped, I know that I am working with my dropped object or falling object formula. H of t equals negative 16 t squared plus h naught. We use this for falling or dropped objects. There is no velocity. So really, my only job is to figure out what's the current height and what's the initial height. And once I have those values, I can solve. Rereading this for this information, I see that it says that an object on Mars was dropped from a height of 237 feet. So 237 is my initial height. I will use this for h naught. This, the height that I'm being asked for, comes from the question. Well, the question says, how long would it take to travel half the distance? So I will do 237 divided by 2, and that is 118.5. That will be my current height. That's what I'm being asked to find. When is it here? So what we set up to solve is 118.5 equals negative 16 t squared plus 237, and you're ready to solve. You can solve this by square roots because there is, I want to fix this line. We have no b term, so this is strictly solving by square roots. Number 2, you drop a pencil out of a window that is 20 feet above the ground. Use the formula. In class, I stressed, whenever you have a formula, highlight it. Where v is the speed in feet per second, and f is the distance fallen. And because the measure is feet per second, I know that that will be measured in feet. To calculate the speed, the pencil is traveling when it hits the ground. So we're going to use v squared minus 64s. S represents the distance fallen, and I'm told that it falls 20, you're starting from a height of 20 feet, so that means it fell 20 feet. So this is a, if you want to make a note, value for S. Substituting that in, this becomes v squared equals 64 times 20. And from there, you can solve for v. Your answer, you're finding the speed. So when you get v equals, whatever your answer is, feet per second. Number 3, a stone is shot from a slingshot with an initial velocity of 124 feet per second from a height of 6 feet. How long until the stone hits the ground? As soon as I see this word velocity, Well, first of all, I don't see any model, so I know I have to build my own. Second, I see initial velocity of 124 feet per second. So right away, I know that I will build my own thrown object model, which is negative 16, h of t equals negative 16t squared plus v naught t plus h naught, where we need to have values for the initial height, velocity, and what I'm being asked for. What height is the question asking me for? What we just highlighted, those three little pieces, will come from the situation. I know my velocity is 124 feet per second from a height of 6 feet, and I'm asked, when does it hit the ground? Ground is 0. Here's my velocity, and it's from a height of 6 feet. So there's my h naught. And then we said ground is 0. So this equation becomes 0 equals negative 16t squared plus 124t plus 6. There is a b term here, so I will definitely have to use the quadratic formula. Remember that to use the quadratic formula, we have to have it set equal to 0. And because I'm asked, when does the stone hit the ground, this is 0 already. So that's nice. Here's A, B, C. Go for it. Number 4. There are 4.5 seconds left in a women's basketball game in which Connecticut is leading by 1 point. Kalina Mosqueda-Lewis is closely guarded under the opposing basket, and it appears that a steal is imminent. She hurls the ball skyward to the upward reaches of the pavilion in a path that can be described by, check it out. It gives us the formula. Let's highlight it. Where h is the height of the ball and t is the time after her throw. The ball is headed towards the 2002 National Championship banner, which is hanging 50 feet above the court. Will it strike the banner and be ruled out of bounds? Something that's very helpful to us is a picture. So if we sketch a picture, I know that my input is t, time. And in this case, I know seconds because it says 4.5 seconds. So time is being measured in seconds, which makes sense for a basketball game. Specifically, a ball being thrown would be measured in seconds. My output, h, is height of the ball. Now we have this banner, right? This banner is at a height of 50 feet. She has hurled this basketball. And I'm trying to figure out, will it hit the banner? Is it gonna be this high? Is it gonna be this high? I just don't know. What is this point called? That is the vertex. So to know if the ball will hit the banner, I need to figure out the vertex. Recall that to calculate vertex, it's x equals negative b divided by 2a. So part A is purely a vertex question and being able to interpret the meaning of the vertex. Question B asks, how long will it take for the ball to land back on the court after it's thrown? Well, if the ball is back on the court, that is ground. And ground equals 0. So we will take the equation it gives us and set that equal to 0. Now, it's important to notice we do not have a C term, and in our notes yesterday, we talked about what we can do, a fast track way to solving this if we do not have a C term, and that is to factor out a GCF. There are two t's here. That's what t squared means. And there's one t here. So that means that I can factor out a single t. So if I factor out t, you need to ask yourself, what's left? And then what do I do with these two pieces to get my answers, my solutions? Because now, if I were to draw you a picture, you are now finding x-intercepts. Because we have set the height equal to 0, and we're finding these values. This is still height of the ball. This is time in seconds. So when you find your answers, you're answering how long will it take for the ball to land back on the court. We're finding values for time. Technically, you could do the quadratic formula. A is -16, B is 55, and C is 0. But if you approach this with factoring, it'll be faster. Either way, you will get the same answer. So to recap this, A is all about the vertex, how high. B is all about the x-intercepts, how far. Question 5. Haven't even read it, and I see that it gives me a model, so I'm going to highlight it right away. During testing, it was determined that the horsepower for an engine is represented by the following equation, where H represents the horsepower and R represents revolutions per minute. So the input R is revolutions per minute, which is also abbreviated rev per minute, however you want to write it. And H, I'm told, is horsepower. And revolutions per minute in thousands. So this is in thousands. Just getting this complete. Okay, so this information I pulled straight from the question. R represents revolutions per minute in thousands, rev per minute in thousands, and H is the horsepower. And we have a definition. Horsepower is a unit for measuring the power of an engine and other devices. We have a model. Fantastic. The question says, estimate the rev per minute, revolutions per minute, at which the engine produces, and here's my given piece of information, 876 horsepower. Round answers to the nearest whole number. This is a value for which variable? Is it a value for H or a value for R? It's horsepower. It's a value for H. So this becomes 876 equals this equation, -59.3 R squared plus 1041R minus 3,676. Definitely going to be a quadratic formula approach here. This is not 0, so you have to take care of that first. And that's it for the hint. I have to stop myself from continuing to talk. Hint complete. Number 6. The height of a rock in meters can be found by the function h of t equals -4.9 t squared plus 540 t plus 25, where t is the elapsed time in seconds, and then I know that h of t is the height of the rocket, because it says the height of the rocket in meters is found by this. So the output represents that height. Height in meters. Find the time or times that the rocket is 750 meters high. and it says round to the nearest tenth of a second. Well, we have to ask ourselves, what is this given information a value for? Is it a value for time, t, or the current height? That would be current height. So we will set up this with our output. So 750 equals negative 4.9 t squared plus 540 t plus 25. We have velocity, we have a b term, definitely a quadratic formula question. Remember, it has to be set equal to 0 first, so take care of that 750 before you use the quadratic formula. Hint, subtract it. Okay, that's all I'm going to say. Subtract 750. Moving on. Number 7, an arrow is shot upwards with an initial velocity of 75 feet per second from a tower that is 125 feet tall. Use the function. Gives me the function. How nice. Highlight it. H equals negative 16t squared plus 75t plus 125. So notice the velocity is right there, v naught t, from a tower that's 125 feet tall. There's my h naught. So there's no need for you to write it. It used that information already and gave you the formula. When does the arrow reach its maximum height? Maximum height should scream vertex. And then how long does the arrow remain in the air before hitting the ground? Ground is when is it at a height of 0. So this is another example of how high is always vertex. How far, we're going to set it equal to 0 and solve for x-intercepts. Number 8, the profit P in dollars gained by selling X computers is modeled by the function. Gives me a function. Highlight it. How many computers must be sold to obtain a profit of $55,000? So X is computers. I'm told that. X is number of computers. And P, I'm told, is profit. So this given information is a value for P. So we'll plug it in for P, and this will become 55,000 equals negative 5x squared plus 1,000x plus 5,000. You need to use the quadratic formula to find the values of x and then interpret your answer. Number 9, the function g of x equals, look at that, I have my function. Given function is used to model the path of a boulder that is being catapulted into the air from the ground, where x represents the distance from the launching point in miles. That's an awful straight line. Try again. And g of x represents the altitude of the boulder in feet. So sketching a picture is always a great idea on all of these, really. So x is distance from launching point. In fact, please draw a picture for all of these because we'll go over your picture tomorrow. Distance from launching point. And that's measured in miles. And then g of x, the output is altitude. And that is also in feet. So this is distance of the launching point, distance from launching point. It's getting catapulted, right? And at some point, we'll come back down to the ground. Selena says the boulder will land 3,500 miles from that point. Is she correct? That's the question. Is she correct? Ground or it says will land. Land means ground. Ground equals 0. So we're going to take the equation it gives us and set it equal to 0. From our day 5 notes on solving by factoring, you should know how to solve this. So go ahead and take a look at your day 5 notes. The SAT questions, there are, let's see, 4 of these questions. These ones I want you to try on your own, and we will compare answers tomorrow. All right? SAT questions, you're on your own. Give them a shot, and we will compare. Any other questions on this, please send me a remind, and please go back and draw a quick little picture of each, because we'll build on those pictures first thing tomorrow morning. Have a great day, everybody.